All right, so welcome everybody. My name is Waltz Treybergs. You have joined the November 2025 MAS monthly meeting online. Unfortunately, the room at the community center was not available to us today, so we're just doing it online. Hopefully, nobody ended up driving there and making a mistake, but I think we made the advertisement pretty clear. So anyway, just to start off, a couple neat comet images that came across my the Slack channel here not too long ago. Earl By and Don Gazdick, both image Comet Lemon. So both it was a nice little comet out in the west in the evening sky in the last month or so. Anyway, let's get going. All right, so the agenda for tonight's meeting is, as usual, do our welcomes, introduce the board. We've got a number of the board members online, and then we'll do a membership update with the statistics from Steve, and then Astro events this month. I'll go through the monthly events, go through outreach requests that are active currently on the MAS forum, and then go through all of the upcoming MAS and related events. A couple shout outs, and then we'll talk about the 2025 MAS board elections and the status of the elections as of today. Then we'll dive into the treasurer's report. Noha is online and we'll be able to present her slides. And then I'll talk about some AL announcements. Jerry does not have any awards. I don't know if he's online, but we can mention a few things from the AL. And then we do have a member presentation. Conrad Sanders will be showing us something, a tour of a facility that he did a couple months ago. It should be pretty interesting. And then a couple more public service announcements, and then our featured speaker, Michael Busch, who I know is online, he will talk about minor planets and asteroids. Looking forward to his talk there. So let's get moving here. So usual slide of the board. Phil Ramsey is not available. I believe he is doing some family business this weekend, some important family business. But I am Walt Strabergs, your president. John Zimich is online. Claire Weaverling is secretary. Noha Reda is our treasurer. Jesse Palmer and Phil Ramsey are board members at large. So if you have any questions about any of the board operations or any questions at all about items responsible for the board, please contact, go onto our website into the board page, and you can make direct contact to any of the board members or all of the board if you wish to do so. So that's how to get a hold of us. All right. Membership update. So welcome new and returning members. So I won't list all of the names here, but please, if there are any new members who are the first time joiners for this meeting, for the monthly meeting, just unmute yourself, introduce yourself if anyone's here. Do we have any new members in the house here on Zoom?
Yeah, I'm a new member.
Okay, welcome, Rob.
Mhm.
All right.
First,
Well, go ahead.
I was just going to say, my first meeting, I've just joined about a week ago, and I'm looking forward to learning as much as I can.
Well, welcome. You've joined a great society. So, welcome. Is there anybody else? Any other new members?
Margaret Hutchinson.
Margaret,
And
welcome.
thank you. Looking forward to this.
Okay. Statistics across, unless there's anybody else who wants to raise their hand. Statistics as of November 1st, 696 members. We upticked a little bit. We just dipped below 700 a couple months ago, but it looks like we're creeping back up toward over the 700 number, hopefully next month. We have 3 honorary members, 158 patron members, 505 regular members, 30 student members. And as usual, if there are any questions at all about membership, please reach out to Steve Emmert, our membership coordinator, and you can contact him through either the webpage or membership at mnastro.org through email. And Steve would be happy to answer those questions. Steve is the one who sends out the welcome emails and the renewal notices and all that good stuff, all the good information benefits for membership. All right, very good. So Astro events, it says October, but it's actually this upcoming month. So this should be November 2025. Anyway, November 10th, conjunction of Moon and Jupiter up there. All right, since we're going to be talking a lot about asteroids, asteroid Papagena is at opposition. So I don't know anything about asteroid Papagena, but that popped up as something that maybe we could snap an image of, or at least a trace of an image of. November 11th, third quarter moon. November 12th, northern Taurid meteor shower. Also November 12th, conjunction of Mercury and Mars, very low on the horizon. November 17th, the Leonid meteor shower. November 20th is our new moon. 21st, Uranus is at opposition. And November 21st, Alpha Monoceratid meteor shower. Another banger of a shower, I'm sure. But it's close to the new moon, so who knows? November 28th, first quarter moon. Also November 28th is the Uranid meteor shower. 29th is a conjunction of Moon and Saturn. December 2nd, the Phenocid meteor shower, another big one. And then the Moon and the Pleiades are close approach on December 3rd. And December 4th, that's the last update before the next monthly meeting, is full moon. So upcoming space events of note, as I'm a rocket guy. So Rocket Lab Electron is slated to launch November 6th. I think they did go. And ULA Atlas V is launching Viasat also pretty soon, upcoming pretty close. But New Glenn Escapade to Mars, and I believe they just they did a static fire a couple days ago, and they announced a potential launch window opening up on Sunday. So Sunday might be the second launch of the New Glenn rocket. Then there's SpaceX Falcon 9 due to launch, Sentinel-6B satellite, and I won't even talk about any of the Starlinks because there's so many of those up there, annoying as they are. And ISRO in China are always doing a lot of launches as well, and again, Starlinks. But what I did want to talk about in the image right here is Voyager 1. So Voyager 1 will be one light day from Earth on November 15th. So that's kind of a interesting little tidbit of that. So a man-made object, one light day away from Earth. That's pretty amazing, and it's still in the sky and still talking to us.
Hey, Vault, can I add something?
Go ahead.
Can you hear me?
Yep.
Artemis 2, since the last meeting, I think they announced the Artemis 2 launch is expected to happen in February.
Yep. That's early next year, and that rocket is pretty prone to slips. So who knows if it's going to stay in February? But again, it's at least it's in the VAB, and it's getting its final assembly, and it should roll out to the launch pad for a wet dress rehearsal sometime in the next month or two. Pretty exciting. All right. So as usual, most of the sky events come up and are available in thesky.org, and free night guides to the night sky. And so that's kind of my primary resource for a lot of that stuff. All right.
Hey, Walt, can I add one thing, repeat one
Absolutely.
thing actually that Clayton Lindsay had put on the forums, and on November 23rd is going to be probably one of the best days for edge-on viewing of the rings, or Saturn without the rings, basically with them edge-on. And also it happens that 6 of the major moons are really visible, spaced out nicely. That's November 23rd.
All right. Good to know. Thank you, Steve. All right, moving into outreach requests. So the outreach, since the observing season is kind of starting to wrap up a little bit, the outreach list is getting a little shorter. But November 21st or through the 23rd at Staring Lake. There's a request for volunteers for a Girl Scout brownie group, and I believe it's at Staring Lake. I'm not sure if that's still there or if it's been moved to ELO. I don't know if Jesse, you know anything more about that. Anyway,
Yeah,
if you do,
it's still at Staring Lake.
okay. November
Yep.
14th or 15th at ELO, Crown College Faith Science Club has a group. So volunteers are looking for there. November 29th at JJ Casby Observatory, there's also a Girl Scout group that has been rescheduled. And so we're looking for volunteers out there. January 10th, this is getting into the winter already, Robert Nate Regional Nature Center in Wright County is looking for volunteers. And then another event at JJ Casby Observatory. It's the Bellwin Winter Family Event, and that is February 7th, 2026. So sign up to volunteer on the MAS Outreach Forum or contact Jesse on the Outreach Slack channel, and Jesse will coordinate the outreach groups and get you in touch with the people who are making those requests. So again, greatly appreciated all the volunteers for the outreach. All right, moving on. Events. So first event I want to talk about is Friday, November 28th, Planets in the Park. So Michael Cowper is got some volunteers lined up, and again, he's gonna do a public intercity outreach event at Pershing Field at 3523 West 48th Street in Southwest Minneapolis. Telescopes, Friends, and Planets, clear, cloudy, and so basically bring your questions. You know, he'll have star wheels, red flashlights, and do a sky tour. All telescopes, all levels welcome. You know, I like his slogan that he put in his email, defying light pollution in a beautiful, accessible city park. So, Michael, we just want to thank you for doing this. Urban outreach is such a key thing for amateur astronomy. So, if you got any comments, Michael, please go ahead and unmute yourself, and you can talk about it. If not, we can move on.
I
Oh, go
Yes,
ahead.
thank you. I already posted a description of it and what we do. I mentioned that we always tell people who it's for families that aren't quite ready to drive out to ELO, and we always tell them about the MAS and the beautiful observatories. That if they go out there, there'll be very big telescopes with a darker sky. And I always tell them about the BSIG because a lot of people, when they come to Planets in the Park, they bring their beginner's telescope, or they tell me that they'd like to learn how to operate the telescope that they got for Christmas or, as a birthday gift. And I send them to the BSIG.
All right. Very good. That's perfect. Thank you, Michael. All right. Upcoming Saturday, November 8th, ELO Public Star Party. And then at 7:30, featured speaker Laura Hammerbeck, NASA JPL Solar System Ambassador, will be speaking. And her topic is going to be When Stars Explode. Key holders and volunteers are always welcome to help. And so watch the Keyholder Forum, ELO forums, and for that. And I want to highlight an image for you. So this is our brand new sign, just put up just weeks ago, I guess, at ELO, the new sign at our primary outreach observatory. So a very beautiful sign, brickwork on below and everything. So I believe Jesse did some of the artwork for that sign. So thank you, Jesse, and thanks Carver County Parks for doing the new sign for us. So just want to highlight that. All right. Beginner special interest group, like Michael was talking about. There are no more observing sessions are planned for 2025. Boo. But the good news was we were 7 for 7 in 2025. So, Suresh, I've got the schedule here posted for the winter Zoom talks. So if you want to talk about those a little bit and anything else, dive right in.
So we're not doing an official BSIG in November. However, I'm not sure if you're going to bring this up later, but the Good Cell thing, are you going to talk about that,
I
Vaults,
don't
or
have a
should I go?
slide for it. I don't have a slide for it, but so you just talk
Okay.
through it here.
So we're basically going to do I'll call it an impromptu BSIG tomorrow at the Good Cell Observatory at Carleton College in Northfield. If you don't know about it, it really is a treasure. It's about 135-year-old observatory that used to be one of the more important observatories in the country because it kept time for the railroads between Chicago and Seattle. I can't remember exactly now. Is it a 24-inch refractor? I can't remember exactly off the top of my head, but they have some telescopes that date back to the 1880s that they still use. And they do open houses every first Friday of the month. And the next one is tomorrow, weather permitting. I'm going to drop a link in the chat here to the forum topic about this, so you can follow. Because tomorrow afternoon they'll update whether it's going to be a go or no go for this event, and I'll post that on this at this link on our MS forum. Aside from that, like it shows here, we have 4 scheduled presenters for this upcoming winter session. Dave Faulkner is going to talk. Dave, are you going to talk about Artemis 2? I think that's what, I don't know if Dave is on or not. I think it's about Artemis 2. Claire, I can't remember what Claire was going to talk
No.
about. Go ahead,
No,
Dave.
no, I'm going to be talking about Titan and the Dragonfly.
Dragonfly, yes. Yeah, I'm really looking forward to that. It's a fantastic mission that NASA's going to do, putting a helicopter on Saturn's moon Titan. I believe it's going to launch still in 2027. Am I right?
That's the plan. Yep. So,
Awesome. If Claire's on, Claire, I can't remember the topic. Do you want
Yeah,
to
I'm
briefly
gonna
discuss
do
what you're going to talk about?
a sampler platter of fun objects for beginners doing visual observing.
Awesome. On the 21st, I'm going to dust off an old presentation on all about telescopes. So we'll talk about all the different kinds of telescopes that amateurs have access to and the pluses and minuses of each one. So if you're interested in, getting a telescope or learning more about it, that'll be what we talk about that day. And Ahmed, do you want to say anything about your talk? I think it's the part 3 of your Middle Eastern astronomy, but I don't know if you have any further
I don't think
details yet.
Ahmed's online tonight. So
Okay. So yeah, we'll post the links to these Zoom meetings on the BSIG forum site. So just keep an eye out for that. Thanks, Valtz.
all right, thank you, Suresh. All right, other upcoming MAS events. So as Suresh mentioned, we do have our field trip to Good Cell Observatory tomorrow night. Hopefully that gets called on. So again, just to confirm, you're gonna post a go no go tomorrow afternoon. Is that correct?
Yeah, if people post, just if you're interested, let me know on the forum on that post. The link I just put in there for the post, and then I will make sure that everybody is in the know on what they decide if it's gonna be a go or no go.
Okay.
It says tomorrow afternoon, so I'm gonna assume, say by 3 o'clock, we should know, I guess.
Okay. All right, then as I mentioned, there's a ELO Public Star Party scheduled Saturday, November 8th from 7 to 10. LLCC Member Observing Weekend scheduled for November 14th and 15th. Watch the forum, because if the weather turns sour and gets snowy and bad up there, then that will likely be canceled. Of course, it'll be canceled if cloudy as well. CGO Member Star Party, Friday, November 14th scheduled. And then the last observing weekends of the year, November 21st and 22nd. Sorry, disregard that one. That was left over from the last month. Then Planets in the Park, as we talked about, Friday, November 28th. And then the next monthly meeting will be at the Andetu Techa Education Center, as in our normal room. We'll have our business meeting. We will be holding elections, and we will be holding a swap meet, and I'll talk about that in a little bit later. Key holder training sessions, we're pretty much wrapped up for the year. ELO is pretty much has traditionally done a website sign up for keyholder training. JJC is a forum sign up and as well as Cherry Grove. LLCC, usually we do training during Northern Nights Starfest and or by special request to a committee member with keyholder privileges. So anyway, look forward to 2026. Hopefully we'll get good sky and lots of new people signed up to be keyholders. It's really a great membership perk for members having full access to any of our observatories, using the equipment, using the high-end very good refractors we have in our domed observatories, using the SETs that we have in our other facilities, using our large Dobsonians, our 25-inch, our 30-inch, and the large Dobsonians that we have at our at ELO and at Cherry Grove as well. So we've got large aperture capability at all of our observing sites and freely accessible to our members. So all right, so next year, become a key holder. All right, I want to do a big shout out to our web team. So as a bunch of people noticed about 3-4 weeks ago, we had a major meltdown of our web page. Basically, all of the bot traffic inundated the forum and the website, so much so that our web host put us in mitigation. Basically, they just pulled the plug on us. And so we quickly had to find a new web host provider. We secured separate areas for both the forum and the website. And we restored first, we got the website restored, and then we upgraded and restored the forum and put in a whole bunch of behind the scenes security details and security things to try to keep the bots out. And so far so good. I've heard that the bot traffic is very, very small, and the forums and the website are running fairly efficiently and snappy. So I got to thank Chris Bethia, John Moravik, and the rest of the web team, Mike, Chris Etness, Clayton, and myself. It was a frantic 4 or 5 day run there, but we got it done, and so got to do thank you to everybody. All right, election. It is election season in the MAS. So the positions for the 2025 elections, the nominations are now closed. They closed yesterday. So the positions that were available are vice president, treasurer, board member at large, 2. And I will say we're not going to announce the people that have applied for those positions, but we do have candidates for every one of those positions. So we will post those candidates with their bios. We're going to post them in Gemini. We're going to post them on the forum. We're going to post them in Slack and all of our, and probably the happenings as well. So the candidate qualifications are being reviewed, members in good standing, and then voting is going to take place on December 4th in our next monthly meeting at 7 p.m. at the meeting. So that'll be one of our official business meetings. And so a couple of the rules: voting by proxy is not permitted. So we can vote in person or electronically. So if you plan on joining and voting online, you will have to go through a registration process, as we've done in several years now. You have to register for that, and then we cross-reference you with a member list and validate that everything that you are an actual voting member. So the other thing is, if a household if you have a household membership, there's only one entitled to one vote. So if it's a couple, there's just one vote per that. Students are permitted to vote, student members. So the timelines, as I mentioned, the nominations are closed, and they were they were due yesterday at 9 p.m. And I don't believe that we've gotten any nominations after that. So everything is in good shape there. As I said, bios and summaries will be posted in the forum, Slack happenings, and in Gemini early in November. So we'll get the list of people out to you in a few days and by next week. And if there's any questions, please send it to boardmember1@mnastro.org. That's Phil Ramsey. Phil is coordinating the elections this year. He just can't be he's not available at the meeting today. But if you have any questions about the election or the process, Phil will be happy to answer your questions on that. So I kind of alluded to, okay, so it is a special official business meeting. So we've got 2 official business meetings per year. One is the election and one is our budget vote, which we plan on early next year. Once we have our budget put together for 2026. So the quorum is we need 10% of the voting membership or a minimum of 50 people required. So in-person voters, when you arrive at the education center, check in at the welcome desk. You'll receive a ballot. Bring a pen or a pencil or writing tool or whatever. And then ballots will be collected before the feature speaker presentation. Online voters, follow the Zoom link for the MAS homepage calendar, and then you will be asked for your name and email. Enter all that information, especially the email address. That's what we use to cross-reference with the member list. And then Zoom will send you a confirmation email with a link to the actual meeting. So that's how the registration process goes. That only happens when we have a voting like this. And then during the meeting, when after the candidates will do their little speeches, we will launch a poll on Zoom, and then you're able to cast your ballot on the Zoom poll. And again, we should be able to tally up the numbers and announce the winner right there that night. All right. So that's clear about the board elections. All right. To entice people to come to the meeting and come to the elections, we are also going to have a swap meet. So December 4th, swap meet. Bring all your stuff to sell. Bring money if you want to buy stuff. I can tell you the MAS has been collecting lots and lots of donations, and we've got a lot of equipment and a lot of extra stuff that we do not need, and we will be selling that stuff at a very, very good price. I will also be posting a lot of items for sale on the MAS marketplace on the forum. So if you're interested in telescope accessories, telescopes, mounts, all that kind of stuff, we're going to be selling a lot of stuff. But the swap meet is available for anybody. Tables will be set up on the perimeter of the room, so first come, first serve. So bring your stuff early to grab the best spot, the best table. I plan to hold the meeting as short as possible. We'll conduct our business stuff. We'll do our elections. Try to get over that as first. I'll skip over a lot of the usual PSA kind of slides, and then we will jump to our featured speaker next month. And then the remaining time will be open for browsing, selling, buying, whatever you can do, and whatever you need. Bring your money and bring your stuff to sell. Everyone wants to buy it, so hopefully that entices everybody. Yes.
So for the stuff the MAS is going to be selling, could there be a list posted on the forum or something of what's available and how much they're asking?
Yeah, we have to put it all together because I know that John has collected a lot of stuff. I've collected a lot of stuff, and we're cleaning out some storage areas and trying to put some stuff up for sale. So we'll try to put a list together on the forum. But larger items I'll try to post separately into the marketplace as I have been doing over the last couple of weeks.
Cool.
All right, so come to the swap. All right, Astronomical League. So Jerry Jones, I don't know if Jerry is online, but He has, according to Jerry, there's no awards this month, but he promised me in December he would have awards, but he might have to be giving out awards while people are walking around doing in the swap meet, but that's okay. Current AL special observing challenges. So T-core bore still hasn't blown, so that's still hanging out there. There's 2 challenge levels there. And then International Observe the Moon Night Observing Challenge 2025. The deadline for submission is November 11th, 2025. So again, if there are any uh, challenges or things you do, the Astro League is a great place to find observing lists to earn these pins. Jerry loves to give out pins. He loves to look at all of the submissions, whether they are astrophotography type submissions or whether they are observing list challenges. So he loves it all. So what does Jerry usually
Get out
do?
there and observe
I don't
or
know if
image.
hopefully everyone heard that, but get out there and observe. All right. Lastly, from the Astronomical League, the RASC Observer's Handbook is still available. Those are a couple good guides, the handbook and the calendar. So the store.astroleague.org available for these kind of things. Really nice handbooks to have for 2026. Handbook is $28 individually, $26 if a group of 10 or more um, uh, buy them. Calendar 24 and 21 again for a group purchase. So if there's any interest, just hook up online and we can make those kind of arrangements. All right, let's move on. So volunteers. So I do want to shout out to all of the volunteers that we have had in 2026, and I really love to see all the people come together. And then last Saturday we did have our volunteer appreciation picnic at ELO. Had a nice turnout. The weather was a little cold and it wasn't clear, but it was noontime, so it was a great picnic. We had great food, good talking to everybody. Just it was good camaraderie, great food again, and it was just a good time. So hopefully next year we'll need more space than just the classroom. We'll be able to go uh, and expand that, get everybody, all the volunteers out there. But right now, but I just want to say one last time, thank you all of the volunteers, and we're definitely going to budget the appreciation picnic again for next year. Good feedback from everybody. All right. Talking about volunteers, how can people volunteer for MAS? So there are currently 2 committee openings. So LLCC committee has an opening at this point, and the outreach committee also has an opening. So if you are an observer, especially if you live on the north side of town or are used to driving a couple hours up to a site, and we'd welcome your help on that committee. So if there's interest there, please email me because I am the committee chair for LLCC. And if somebody is interested in joining the outreach committee, please email Jesse at outreach@mnastro.org. Other ways you can volunteer are making member presentations. We love member presentations in all of our monthly meetings. We're going to have one a little bit later here, coming right up. Write articles for Gemini. Father Brown is always looking for articles. You can help us on the web team. As I said, it was a huge effort by the web team to get us under control and get our web resources back doing. So that's a big job. Join any of the other committees. There could be other committee openings popping up. But always you can help out at public star parties at ELO if you're a key holder, or just become a key holder. You can help out at Cedar Creek, and of course always at BSIG. And then always there's there's opportunities to do outreach, whether it's sidewalk astronomy right in the city or whether it's at one of our observatories. So if you have any interest or want to offer your volunteer help, email info@mnastro.org. That comes to it comes to secretary and myself, and we will relay your desire to help to whoever you want to help. So thank you for doing that. All right, presentations. So coming right up, you'll hear a presentation from Conrad. And then basically, we're looking for any short presentation. It could be a 5 or 10-minute talk about observing campaigns, astronomical objects, history, dark sky adventures to astronomical sites. If you're building a new ATM project, new telescope, a new mount, if you're restoring something, outreach, some special outreach project, observing your imaging techniques, research topics even software and telescope how-tos for astrophotography, talk about manned robotic space missions, or even go back to the Better Know a constellation back up from days of past. So it doesn't take any experience is fine, and it's a great way to get experience doing presentation in front of people. So if you have anything to talk about, we'll probably want you to talk. So send an email to Ahmed at programs@mnastro.org, and we will find a spot for you in one of our presentations. It might not be the very next one. We might ask you to delay it if we got a couple stacked up, but we will get you in front and get you talking. All right. Talk about member presentations. So the November 2025 member presentation is by Conrad Sanders, and he did a tour of Planewave instruments. So Conrad, you are online.
So this is a short presentation. This is something that I did this summer. I'm sure, I don't know if any people are aware, but we had some issues. We've had issues for a number of years with the Planewave down at Cherry Grove, and so we decided that we needed to, to get the thing repaired. So I elected to drive it, to drive the Planewave was taken off. Mark Job and I took it off. I believe it was in May, some early summer. And to save money, I decided, well, I'm retired. What the hell, just take a drive. And it was a drive. It's 3 hours east of Chicago in a town called Adrian, Michigan. And while I was there, I thought, well, I drove 11 hours. I should really get a tour of the place. So Planewave was kind enough to to give me a tour. So this is kind of an overview of what I did. And I did this at the end of July. So anyway, so I'm just going to go over some of the things that I learned about Planewave. And okay, can you see hopefully my next slide, right? You can see that?
Yes.
Yeah.
Okay. A lot of words.
Okay, a lot of words, yeah. So this is just a kind of a background with Planewave. Planewave Instruments was founded in 2006 by Richard Hedrick and Joseph Haberman to build high quality scopes. They developed the corrected, as we know as a CDK, optical to create a large flat field telescope suitable for imaging. And they're really a pioneer now with their scopes for like space situation awareness. So I think they even have some government contracts to monitor asteroids or whatever. So it's quite an operation. The history behind the optical design is while working at Celestron, both Haberman and Hedrick collaborated with David Rowe, who designed the CDK. And the CDK uses corrective lens to produce a large, perfectly corrected flat field for large format imaging cameras, which was a big significant improvement over existing designs. One thing I had learned is that when they were at Celestron, Heberman Hedrick tried to get Celestron, to adopt this, but Celestron wasn't interested. And that's kind of where, I think one of or both of them broke off and got Planewave. So there were Celestron just wasn't going for it. So it's funny now because with Celestron now with the RASA, David Rowe was involved. His name's on the RASA, and it helped design the RASA. So I think they got kind of some ideas from these guys, but anyway, they basically just split off on their own. So Planewave Instruments, their headquarters in Adrian, Michigan. The town is about 12,000. It's a very small town, and it's located on a former campus of Adrian Girls Training School. The facility houses company's state-of-the-art operations. They manufacture and test astronomical telescopes, including their signature CDK. The campus hosts public events such as annual open house and science expo, offering a glimpse into the art of science and astronomy. And I'm telling you, when I drove up to this place, I couldn't believe it. I thought, am I in the right place? I mean, it was almost spooky because it was just this gigantic, it looked like abandoned campus of all these buildings. And I couldn't believe it. I had pulled up and I saw the sign. It's like, oh, this is it. So yeah, they're really involved, public out events. And this next slide here kind of shows you, the picture of one of the buildings. And the history was, this property was championed by Quaker Laura Haviland, a famous abolitionist, suffragette, and social reformer. And then Underground Railroad, it became part of the prison system in 1891, and then it was renamed the Girls Training School. And then the school was abandoned by the state of Michigan, triggering the city to purchase it for $1. And then their Hedrick or the other guy, Haberman, they decided, I think one of them was from Adrian, they decided to look for new headquarters outside of California when they were done with Celestron, and they decided to move their headquarters here. So they have purchased the property in 2018 and invested millions in upgrading the facilities. So interesting place. So the next slides are basically just going to, I'm going to just go through some of the telescopes that I saw there, and I have a description of each one that I witnessed there. Okay, so here's one of their units. This is a CDK 24 astrograph. It covers a 70 millimeter field of view without any curvature, and the cost for this one was $73,000. And you can see the specs down here: the aperture, the focal length, focal ratio, and the weight. So pretty cool. And then we got another one here. This is a monster. This is the RC 700 telescope. It's engineered for elite astronomers and astrophotographers who demand precision and scalability in their astronomical endeavors. It is equipped with an RC 700 rigid Creighton optical tube and a high-performance direct drive mount, making it an exceptional choice for advanced research, deep sky imaging, educational purposes. So this is housed in a container, so it can be left out pretty much year round in this enclosure. And this one here, $275,000 for this monster. So, I mean, look at the weight on that thing, is pretty incredible. And then, let's see. This one here was an RC700 without optics. And then this one here, this is an enclosure. Happens to be just the enclosure for a 0.7 meter system, and designed to regulate temperature while the enclosure is open and draw circulation through the slit to improve local astronomic seeing when in operation. It's designed to withstand 120-mile wind gusts. Interiors are insulated to protect from condensation, thermal effects, while the exteriors are pervious to rains with no fog and debris. So this was sitting outside in their parking lot. And then this one, this is a weatherproof system. I guess this system is driven by AI and custom-made software to capture images. So you see the previous one was just the enclosure, and then this one here is just considered, weatherproof. And again, they leave this out pretty much. It's pretty much contained. Here's a PF1000. This is a 1 meter f2.3, 850,000. I wasn't able to get a lot of specs on this. A lot of this stuff they provide me, and then I just Googled to get some of the information on this one. So here's the T600 mount. It's a high torque double stack direct drive motors for zero backlash. Has high resolution encoders for ultra precise positioning. It has enhanced organization with double layer labyrinth seals on each axis, and then has advanced point XP mount modeling software included. So I think I remember seeing one of these when I was out at the Advanced Imaging Conference in San Jose with the last one they had. So some of this stuff looked familiar to me. The gentleman here is the guy that gave me the tour of the facility. I've been working with Cameron, but he wasn't available, so one of his coworkers was nice enough to give me the tour. So. And then here's a CDK 1000, and this is the elite. I mean, this is the monster. I mean, this is state of the art drive mounts. It's 3,500 pounds, $600,000 on this beast. So these guys are serious on what they do.
Conrad, I think this is the telescope that I saw at Saratololo. There were like 3 or 4 of them that a university had up there.
Oh, okay. Okay. Yeah, well, it's just incredible. I mean, it's just mind-boggling what they do. They're extremely busy. I mean, they're so backlogged with orders that people are ordering these things. I don't know if it's government agencies, or I think a lot of it's government, but they're very busy. This next image, they didn't give me much on this. This is a prototype, and they don't want to share this. Let me take the picture, but this is in works. This is in the works right now. I'm not sure what they're going to be doing, but they got some plans. It's probably going to involve, I don't know, AI or something. I don't know, but they were really mum on this. But like I said, they let me take a picture. This is a portable observatory that they have. It's pretty much put your system in there, close the cover, and pull it behind your car or whatever, So I think I've seen these before in magazines, but it was really cool to see this setup. And then this is their large system test tunnel. This is vertical test tunnel. They multiple horizontal test tunnels for their 12.5 24 optical systems. So there wasn't anything in there at the time, but it was interesting to see what this, because at first I had no clue what this was, and pretty cool operation. They're called mirror polishing robots. So this is where they do the mirror polishing. So they've got this all done by these robots. So that was interesting to watch. And there's water in there spitting on it and grinding away, and multiple stations with this. Pretty cool. And then here's another one. Same kind of thing, but a little bit bigger on it. So one of the things that came out of this, I learned, is Elon Musk now has a vested interest in Planewave. I'm not sure how much he does, but he has interest. He has some vested interest in it. So it could be 5–10%, who knows? That doesn't surprise me. He's got his fingers in everything, but very interesting. The other thing I found out, there's a current project to work with the developers of Nina to integrate software to work with their Planewave telescope. So I found that really interesting. So they just start doing that. So they have some things coming up. Maybe that's what all that compartment where they couldn't share any information, that's what they're going to tie it into it. But I found that very interesting. Okay, so this next slide, this is me all packed up here. This is the Planewave CDK in the back of my car. Loaded it up, drove 11 hours, pretty much straight. Horrible Chicago traffic, but I drove straight through. I wanted to get home a certain time, 11 hours. And then we found out some information after it sat there for about a month before I started getting feedback from Cameron, getting emails and what the problem was. And basically what they said that they would normally charge $100 an hour to fix this. But when they looked at it and inspected it, they said there will be no charge. And I thought, interesting. And to me, it was maybe admitting a flaw, and there was a flaw. And I have something I just read from the other day. I'm asking him again. He says I'm with the mirror, but I want more specific. So he just responded to me the other day. He said, we found some issues with the primary mirror, which had some high points towards the edge of the mirror. This was not caught in our testing, but it is now. And so we ended up needing to rework the mirror, and that solved the issue. So, the bottom line is they came out and they had a flaw in their manufacturing process. And, we had this scope for years with this problem. And so, with the board's approval, we budgeted so many dollars. But then I thought, I'm not real crazy about driving all the way back there again. And because we saved the money, we over budgeted. We elected to have, after Vault's approval on the board, to have it shipped back. And so here's the Planewave back in my driveway. I basically stored the Planewave in my tough shed for early part of the summer, and then packed it up and drove it. And then we got it back in this very nice shipping container. And so that's just the guy with the picture delivering it. This next picture shows, and I took this when I was down there, I think last week or the week before. The problem we had, we've always had this, is we got the left side, which is the most current with the correction, and the stars look excellent. The problem on the right side was the flaring that we had, that everybody complained about. And so you can see that it's corrected. I mean, what they did, they fixed it. We got it taken care of. And then the last slide is an image that I took of M15 just about a week ago. And it just looks fabulous. I mean, there's the flaring problem, it's all gone. Now there is a little goofiness looking at the center of the core here because I didn't have flats generated, so I kind of probably overexposed here. But I put it into a quick, these are 5-minute exposures too, so the core is really blown out, but I would normally not do that. But we wanted to, Mark and I wanted to see that after we did the PEC, which we had to do because we were taking 5-minute exposure, we noticed some drifting, that we want to take a 5-minute exposure. But normally you wouldn't take such a long exposure at this bright, this M15. But it definitely shows that the problem is resolved. So anyway.
Well, thank you, Conrad. I'm really, really encouraged with the final results of how the Planewave is going to be. And once you guys integrate it with Nina and get all the documentation going, that scope will become available to our key holders down at Cherry Grove. So again, thank you for the presentation. Really cool to see the high-end optics that we can't that us amateurs really have couldn't afford, but it's you can always go and drool.
Yeah, and I want to give a big thank out to Mark Job. I mean, he I couldn't have done it without him. I mean, we worked. We actually took the Planewave up to his observatory and tried to do this by doing a yoga pose to look at Vega, trying to figure out what the problem with this scope was. And we were all in different twists, looking up and trying to figure it out. And it just got to a point we just decided, it's just beyond us. And we did the right decision. This had to be repaired by them. So, yeah. So anyway, hope you enjoyed
All
that.
right, thank you very much, Conrad. Yeah, thanks a lot. All right.
Waltz.
Yo, question, yeah.
Yeah,
Go
Dean
ahead.
here. While Conrad was talking, I was kind of trying to figure out where he went, and I discovered an interesting fact. I don't know if Conrad knows anything about it, but Planewave Instruments doesn't show up on Google Maps, but there is a company at the exact same location as their website says they're at called Observable Space.
Oh, interesting.
Apparently they're going by a different name at some level. Maybe that has something to do with Elon Musk having an investment. I don't know. But
Oh, could be. Yeah, could be. Yeah, like I said, this little town of 12,000 people, and it just blew me away. I mean, this huge campus. I mean, just acres of all these buildings, and some of them are being used. Others are just abandoned. I mean, yeah.
One of them's an art center. I noticed on the website.
Yep, exactly. Yep.
Can I ask a quick question about the tour he did?
Yeah.
Quick. Conrad, I want to say thank you for doing this, and to the CGO Imaging Committee. Thank you for getting this scope fixed. Hey, just real quick, when you talked about these guys originally being Celestron employees, my understanding is that they still have a fairly cordial relationship with Celestron, and like CPWI, the software, was a collaboration, right, between Planewave and Celestron.
It was with Planewave. Yep, I run it all the time. Yep.
Did you happen to hear anything about any further collaborations with Celestron? Anything they're working on?
I didn't. I just know that they wanted to really pursue this Celestron, and Celestron, my understanding talking to Planewave, is they wanted to go a different direction. Celestron, so that's pretty much where they decided to go out on their own, and but you're right. CPWI was developed between Planewave, so. But I really don't know what it is right now, the relationship. But I mean, David Rowe, I mean, he brought in the RASA for Celestron. So,
Right.
Yeah.
Well, thanks again for doing that, Conrad. It was great.
Sure. Thank you. Thank you all.
All right, any follow-up questions, or let's move on? All right, let's move on. All right, loaner scope program. I'm just going to briefly discuss it. So that's another one of our member perks. We've done a lot of loaner scopes over the years and over this year. Basically, you sign up on the web form. Membership will be validated, and then you make arrangements with Antone and pick up a telescope in his driveway, and you can have a SET or a Dobsonian or a refractor in your possession for a month. And then also available are DVDs, a large collection of DVDs. All of the whole collection is available on the webpage. So go to our website, Loaner Scope Program, and you can sign up and borrow one of our scopes as a membership benefit. Weekly happenings. Every Tuesday, our secretary Claire sends out our MailChimp newsletter, and basically you can sign up for the MailChimp newsletter on the website if you're not already not getting it. Basically, and also if you have anything to announce club-wise, send it to secretary@mnastro.org the week before, probably Friday or Saturday, and then Claire will queue it up for transmission for sending out on Tuesdays. So that's a weekly happening. So online communities, as always, we're on Slack. We're active on the forums. We have our active forums. We have a YouTube channel. This presentation and all of our presentation and the BSIG presentations are all archived on our YouTube channel. And we are active on Facebook, Instagram. So please follow all of those pages. And if you want to share any of your media, send your pictures, watermarked, of course, to social media at mnastro.org, and Chris will get those posted. We still have our Cafe Press store, so you can get to that from our webpage and buy the MAS merchandise. And then, of course, Gemini, several times a year, we get our PDF newsletter sent out, and we're always looking for experiences and articles for Gemini as well. All of the Geminis are archived on the website and in a searchable database. So at this point, I would like to introduce our featured speaker, Michael Busch from the SETI Institute. He's going to talk about small objects in the solar system. So Michael is a research scientist at the SETI Institute. Previously, he worked as a postdoc position at UCLA's Department of Earth and Space Sciences, Associate Professor Jean-Luc Margot. Michael received his undergraduate degree right here in U of M in 2005 and his PhD in planetary science at Caltech in 2010. His thesis research, he worked with Sri Kulkarni at Caltech and Steve Ostaro at JPL. So he's a planetary astronomer. So let's turn it over to Michael, and let's learn some about small objects in the solar system. So Michael, I will stop my share, and you can just dive right in.
All right. Thank you, everybody. And hello again to everybody watching live and also anybody who is watching on YouTube, since I understand this goes up there after some delay. I am going to put on screen sharing so you can see my slides. I do not have the ability to look at the chat while I am doing that. So if anything I'm saying is really confusing, please interrupt. Otherwise, we should have time for questions at the end. And just make sure you all can see the slides.
Yes.
Yes.
And we are advancing okay?
Yes, sir.
Okay.
Yes.
So this is a chart of the inner solar system out to the orbit of Jupiter as of last week when I put the slides together. We have Earth here, of course, it being this time of year, Jupiter out there, the Trojan clouds in front and behind. We have Mercury, Venus, and Mars. And then the main asteroid belt is the big band between Mars and Jupiter. So all the dots there are different asteroids on their own orbits around the sun. There's also comets passing through. So we've got lots and lots of stuff other than planets that are orbiting around the sun. When I give this versions of this slide to grade school students, I need to explain why there is an asteroid belt. I explain that you can go out and see the Orion Nebula this time of year, and you see all the gas and dust collapsing down, forming stars, and material settles down into disks because otherwise it's running into itself if it's going too fast sideways to fall into the middle. So within that disk, stuff clumped up. Randomly in our solar system, Jupiter happened to get so massive so quickly that it accumulated all that extra gas. And then it's more massive than everything else in orbit around the sun put together, and it scatters the orbits of all the stuff around it. So in the asteroid belt, we didn't get a second Mars. Instead, we have many, many, many asteroids that never accumulated up to give us.
Question?
Yes,
Yeah. Does the bulge on the opposite side from Jupiter have a name?
I'll get to that. So we have stuff in the asteroid belt never accumulated up to form planets, and we don't have anything right near Jupiter because the orbits there aren't stable. The ones you see that are plotting near Jupiter, there's not many of them, and they're on very inclined orbits, so they're way out of the ecliptic plane. We have the Trojan asteroid clouds, which are only stable because they are in front of Jupiter and behind Jupiter. There are the Hilda asteroids that are in a 3-to-1 orbital resonance with Jupiter, so they get out to aphelion when Jupiter is not there. And so right now, the Hildas that are at aphelion are the ones where the Trojan clouds are, and then the ones that are opposite Jupiter. They're separated by 120 degrees at aphelion at any given time. There are more Hildas that are closer in, passing through the asteroid belt, and thus safely away from Jupiter at all points in their orbits. But even in the main asteroid belt, when asteroids run into each other, the relative velocities are so high that they usually erode rather than accreting. And so we end up with asteroids that look like this. I, again, have to explain the difference in terminology here. Giuseppe Piazzi, he found Ceres back in the very beginning of the 1800s. He called it a planet. And then there was Pallas and Juno and Vesta. They were all called planets. But then there was 40 known asteroids, and people stopped calling them planets. Then people found Pluto out in the Kuiper Belt, and that got called a planet. And then in the mid-2000s, late 2000s, there was the whole argument of what is a planet and what is a dwarf planet. So we now have this category of things that are big enough to be around, but not so big as to be the biggest single thing on that set of orbits. And thus, Ceres and Vesta, the two largest asteroids here, get called dwarf planets. And you could argue about Vesta and some of the stuff in that size range because, well, Ceres is as big as Texas and very nicely round. Vesta has lost a few percent of its volume to these big craters at the South Pole. So what counts as being round enough to be a dwarf planet? I don't really care. But Ceres and Vesta are in one category, and then all the smaller stuff, at least that's on this picture, is definitely different. So Letitia is a pretty typical main belt asteroid. It is 80 kilometers long, 80 miles, 130 kilometers long. It's very, very lumpy. It's lost large chunks of itself to impacts. But this is still 4.5 billion years old. So this is a remnant of planet formation. All the smaller asteroids on this picture, I'm not talking about the comets at the bottom for the moment, are much younger than the age of the solar system. So these are remnants of previous asteroid-asteroid collisions. And Matilda, just to take one example here, just barely survived the impact that made this crater. And all the smaller ones, they'll eventually be broken up by collisions or some other processes that I will talk about. But this gives all the smaller asteroids a very peculiar structure, which astronomers have creatively decided to name rubble piles. It's descriptive. So you have here the asteroid Itokawa. This is this small dot on the previous image. We zoom way in now. This is from the Hayabusa spacecraft, which is from the Japanese Space Agency and got to Hayabusa to Itokawa just 20 years ago now, which is amazing to believe it's been that long. But it's a pretty typical near-Earth asteroid we found. It's about 1/3 of a mile long, and it looks like two pieces of material sitting on each other. We call this a contact binary shape. The gravity is 10,000 times less than what we have on the surface of the Earth, so the rocks don't slump down. But there's no air or water here because there's gravity. There's no gravity to hold those in place. Anything that outgasses immediately escapes. But something has sorted out all the material on the surface. The largest blocks are the size of the International Space Station, but next to that, there's dust. So how do you separate out material like that in microgravity without any fluid to do the job for you? We can end up thinking about things like electrostatic charge. Solar wind is coming in from the left along with the sunlight. drops protons and electrons randomly on the surface, you can get a fairly significant amount of charge building up and move material around. We can talk about the entire asteroid getting shaken up in a collision. These things are so small that we don't have the normal craters that you get on a flat planetary surface. Instead, you get more irregular structures and you shake the whole thing around. You can sort material that way. And we also have effects of radiation pressure. So light carries momentum, not much, but it's there. And if the gravity is very, very low, it adds up to meaningfully push the asteroid around. This is the Yarkovsky effect. Ivan Osterovich Yarkovsky was a Belarusian engineer who worked it out theoretically. Then it was seen with the Echo spacecraft in the 1960s because they were very big balloons. They're very lightweight, low mass. Sunlight pushes them around very easily. Asteroids are much heavier and denser, but they get pushed around, but more slowly. And if the shape is irregular like this, we have something we call the Yorp effect, the Yarkovsky-O'Keefe-Radziwiecki-Paddock effect. You can see why we use the acronym. But those are the various scientists involved in working this out. The sunlight hits the asteroid, it's irregularly distributed. The outgoing infrared light from the thermal re-emission from the surface is also irregularly distributed. If it's not centered on the asteroid's center of mass, it gives a torque. And over time, that can spin up the asteroid and reconfigure it. So Itokawa here may have been two pieces in orbit around each other at some point, and the radiation pressure torques very slowly made them recombine. And then at some other point in time, it may get twisted around again and reconfigure itself. And this gives you another process for switching around the surface and interior structure of the pile of rocks. So it's another reason to study these things. We learn about the history of the solar system, but they're also just really, really weird as compared to normal planetary geology. Now, there is a motivation to study the near-Earth asteroids in particular. The asteroid orbits I showed you, the ones in the main asteroid belt, are stable, except that Jupiter occasionally scatters the orbits around. Saturn does some too, and so does Mars, but it's mostly Jupiter. And radiation pressure is pushing them around, so they migrate, and sometimes they get into orbital resonance with Jupiter that sends them into the inner solar system. And then their orbits are crossing the orbits of the inner planets. And those orbits aren't stable. Over millions of years, the entire near-Earth asteroid population is getting replaced because the asteroids are getting destroyed. Either they get hit in a collision and break apart, they can get spun up by the Yorp effect until they explode. This is called rotational bursting. It's dramatic to watch when it happens. Sometimes the asteroids orbit gets so eccentric they fall into the sun, or they bake off and evaporate like Phaethon is doing for the Geminid meteor shower. Sometimes the asteroids hit something, and sometimes that is the Earth. So on the left, you see a few examples of asteroids that were discovered in space before they hit the ground. So these are small asteroids the size of my desk. They tend to be found in the winter in the northern hemisphere because that's where most of the survey telescopes are, and that's when there's most of the observing time. So we have examples from Niagara in Ontario, Normandy, and Brandenburg. Nobody wanted to go swimming in Lake Ontario to pick up the meteorites dropped by this one on the top. But one of my colleagues from the SETI Institute, Peter Niskins, is a professional meteor chaser. So he got to go to France and Germany to pick up the pieces from those impacts. Now, all those do is drop a few meteorites, and people run towards the explosion rather than away. There are fewer larger asteroids than there are small ones, but the larger ones do sometimes hit the Earth. Many of you may remember 10 and a half years ago now, sorry, not 12 and a half years ago now, time keeps passing, a place called Chelyabinsk in Russia, city of about 1 million people, an asteroid the size of my house impacted the atmosphere above the town. So all the energy of its motion gets converted into heat and light and sound, and there's a bright flash of light in the sky that's briefly as bright as the sun. A lot of people ducked. Other people had no reaction at all. There's some dashboard camera videos. One person's going to work, he just pulls down the sun visor and keeps on going. That would not have been my reaction. A bunch of other people ran to the window to see what the bright flash of light in the sky was. The problem is that the shock wave travels at the speed of sound from the airburst. So 30 seconds to a couple of minutes later, depending upon where in the city people were, the windows got blown in from shockwave. Nobody died, but there was about 1,600 injuries, mostly from broken glass. So we'd like to know about things like Chelyabinsk before they happen if they're over places where there are people. The last time there was one like Chelyabinsk before that was over the Southern Ocean way south of Cape Town, and nobody really noticed. But we'd like to know about these in advance if we can. We'd also like to know about larger things, which again hit less often. The motivation here goes back to the 1980s when Louis and Walter Alvarez worked out that there was a mass extinction event caused by an asteroid impact that killed off most of the dinosaurs and quite a lot of other things. And then later in the 1980s, the crater was found under Chicxulub in Mexico. So this is the northern end of the Yucatan Peninsula. Half the crater is now underwater and under 66 million years of sediment. But on land, there's this fracture pattern and a very nice circular arc around the rim of the crater from the impact shattering the limestone in the Yucatan basement layer. And you can go pick up fossil meteorites from that if you look at 66 million year old ocean sediment on the other side of the world. So we'd like to know about any dinosaur killers anytime in the foreseeable future. And this was the original motivation for finding as many near-Earth asteroids as we can and plotting their orbits. So all of this gets done with large survey telescopes. I do not work on these myself. Many of my colleagues do. The most active ones are the Catalina Sky Survey in Arizona and the Pan-STARRS project in Hawaii. There's also the Vera Rubin Observatory, which is just beginning operations in Chile. They have some gorgeous test data that's come through. They'll discover many more asteroids and will cover the southern sky better than it has been. Because again, most telescopes are in the northern hemisphere at the moment. And there's also been asteroid surveys from space because, of course, half the asteroids on our Earth-crossing orbits are on the inward side at any given time. And thus, we would want to know what's in the direction of the sun. But hard to do that during the daytime because the sun is up. So if you go to space, you can use infrared telescopes and see the dark sides of the asteroids, and they're still emitting heat, and you can work near the sun. This was done by the Wide Field Infrared Space Explorer, which has since deorbited. It was not designed for this. It was an astrophysics project, but Amy Mainzer convinced everybody that it was a really good idea to add an asteroid search mode. And she is now leading the NEO Surveyor mission, which is to do the same thing much more extensively. So all of this together got lumped together, all the different survey programs, as something called Space Guard. It's a very old science fiction reference for those who didn't read that book. You see here the discovery rate goes up in the 1990s as soon as digital cameras become available and we do not have to do photographic emulsion. I am glad I never needed to work in the darkroom because that seems really annoying. But the digital cameras are also much more efficient than film, so the sensitivity goes way up. And initially, the discovery programs focused on 1 kilometer and larger near-Earth asteroids. This was largely the Linear project, which is in blue on the chart. Discovery rate there peaked around 2000 and has dropped off to almost nothing. So we have found all the asteroids on Earth-crossing orbits that are 1 kilometer across or larger, and none of them can impact any time in the next few hundred years. There is one possible impact in the year 2880 by an asteroid called 1950 DA. The telephone number tells you that it was found in 1950 initially. It then got lost until 2000. And then we've observed it since then as we can. It's been annoying me for the 20 years that I have been doing asteroid stuff that we can't quite rule out that impact yet. Give us another 10 years and we probably can. But it's 855 years out. We have plenty of notice. The focus since then has been on finding smaller asteroids because the smaller ones can still be a problem. And the discovery rate is now about 3,000 objects per year for all of that, for the near-Earth objects. And the numbers for this year, of course, are not yet final. Now, we don't give these things names anymore. You've seen the telephone numbers. They're called provisional designations. If you want to look up the IAU names, they are telephone numbers assigned based off of 2-week periods within each year. So this one, 2024 YR4, was found in December of last year. And initially, we had a prediction that it has about a 1% chance of impacting the Earth in 2032. So this object is about 60 meters wide. It can cause regional damage. The Tunguska event in Siberia in 1908 was a little smaller than this. So it's way bigger than Chelyabinsk. But 1% of impact, what does that mean? Initially, we measure where the asteroid is on optical survey astrometry points, and they fit a tracklet to the orbit. We can only measure the speed so well. The uncertainty region tends to spread out with time along the orbit. So there's a big arc that forms a path that intersects where the Earth will be in 8 years. Indicated procedure, go get more data. And a lot of the follow-up here was actually done by amateur observers. The object was bright enough for a certain amount of time, and you just need a telescope pointed in the right direction with good sky. There's a project called the Minor Planet Mailing List, which some of you may be aware of. I'll stick a link into the chat later if other people want to look that up. But we get more data with both amateur and professional telescopes over the next few months. Early this year, the uncertainty region shrinks with time, and as it gets smaller, the Earth occupies more of it, so the impact probability goes up. But eventually, we can confirm that in 2032, 2024 YR4 will be about a lunar distance away and will not impact the Earth. Yay. However, in this case, it turned out there was an additional complication. This is a two-dimensional representation of three-dimensional space. But it happens that in this case, the line of uncertainty region for where 2024 YR4 will be in 8 years actually does run across the moon as well as across the Earth. We've excluded the Earth impact, but now there's a few percent chance of a lunar impact in 2032. This is not a hazard for anybody on Earth, but it is something that you would care about if you are, for instance, running a spacecraft in lunar orbit, because if it hits the moon, it will throw up ejecta. And some of that ejecta will get up to the heights of low orbiting spacecraft, like the Lunar Reconnaissance Orbiter that is currently around the moon. So the indicated procedure here is to come back again and observe 2024 YR4 next February. That will have to be done using JWST because it's very faint and far away from the Earth at that point. But that will hopefully let us rule out the moon impact completely. And then in 2032, it'll most likely fly between the Earth and the moon, and that'll be cool to watch, and it won't be a problem for anybody. So that is a large chunk of what we end up doing for the near-Earth asteroid work, in particular, is just check possible impacts and rule them out. My own contributions to this have mostly been using techniques of radio and radar astronomy. So I worked with the National Radio Astronomy Observatory for a while in there amongst my postdoc. The basic technique here is to have a large radio dish. This is the Goldstone Deep Space Network site in Southern California, which is used by NASA for communicating with spacecraft, but we have some permissions to do astronomy with it. We used to use the Arecibo Observatory in Puerto Rico until it collapsed 5 years ago, but the same basic technique was used. We have a transmitter mounted here, bounces off the secondary, bounces off the primary, and the beam goes out into space. It bounces off the asteroid we are looking at. That gets reflected back to the Earth. We time how long the signal takes to go out and come back. That gives us one resolution dimension of distance from the Earth. The objects are spinning, so Doppler shift of the signal tells us a second dimension of resolution, which is related to the actual shape in a fairly complicated way, but we can disentangle it if we have enough different images from different angles. And that's what you see here, a few different examples of radar images of asteroids. They, again, have their telephone numbers based on where they were found. The important point for this one, the top left, is that the asteroid has lots and lots of these little radar bright dots on the surface. And some of those are high standing above the surface around them because we can see them behind the trailing edge of the echo, so they're sticking up over the terminator. This is another rubble pile, and we see whenever we've got resolution good enough, basically, the asteroids have rocks on them. So they're all rubble piles, at least in the Earth ones that we can see. Some of the very smallest ones are probably single solid blocks. They spin too quickly to be held together just by the weak cohesion between gravel. But most of them are piles of rubble. We see a lot of contact binary shapes, like the one I showed you before. This is another asteroid like that. And then we also see binary asteroids. So Asteroids spin up under Europe effect torques. They bulge out around the middle, they shed material, and now we have two pieces in orbit. Or a contact binary can spin up and break apart. And the mutual orbit is affected by radiation pressure again because the shape has changed. It's affected by tides, it's affected by passages by different planets, but we can still fit the orbits amongst the components of multiple asteroid system. There are some that have two satellites and not just one. And that tells us, among other things, the density of the rubble piles here. We find that some of them are less dense than water. So you've got rocks with a density of 2 and an aggregate with a density of 0.95. That means it's a little more than half empty space. So very loosely held together. This matters for models of asteroid formation and evolution. It also matters for discussions of asteroid deflection. And I'll get to that in a few minutes. This slide keeps getting busier, which is a great problem to have. So the near-Earth asteroids are coming near the Earth as compared to the scale of the solar system. That makes them attractive targets for spacecraft missions. Some of them are easier to get to than the moon in terms of fuel. Crucially, all of them are easier to get back from than Mars in terms of fuel. So we're just now talking about sample return missions from Mars by NASA and the Chinese Space Agency. There have already been 3 different asteroid sample return missions, and a 4th one is in progress because you don't need a really big, heavy return rocket to go along with you. So the first asteroid mission was 25 years ago now by NASA to the asteroid Eros. And then we since then had missions by the Japanese Space Agency, the Chinese Space Agency, the European Space Agency, and the Canadian Space Agency in different capacities to many different asteroids. The Hayabusa 2 missions and OSIRIS-REx missions are still in flight. They've gone to their target asteroids, picked up rocks, put them in the sample containers, flown the spacecraft and the sample containers back to Earth, dropped the sample containers on Earth, and the spacecraft then sent off to the side to sling by Earth and go to other asteroids entirely, which is a long, complicated series of events, but it's worked remarkably well. The Destiny Plus mission is to be launched by JAXA soon to go by the asteroid Phaethon, which is the source of the Gemini meteor shower. It's also to visit the asteroid Apophis. Some of you may recognize that name. Apophis is going to do a very close Earth flyby in 2029 in April. It is not going to hit the Earth. It'll pass closer than the geosynchronous satellites, but nicely out of the equatorial plane, so it doesn't actually pose a hazard to any spacecraft. The OSIRIS-REx spacecraft by NASA is going to rendezvous with Apophis after the flyby. The Destiny Plus spacecraft is to fly by Apophis before the flyby. And then there's a proposed mission from the European Space Agency called Ramses, which would also go to Apophis, and there's been discussions of other Apophis missions by other space agencies, as well as other space agencies proposing to go to do other asteroid missions. Some stuff I hear rumors of from the South Korean Space Agency, some from the Indian Space Agency, so I'll just note how international all of this is. No one country or group of people is doing these missions, but together they make a pretty impressive set of things that we've done to study the near-Earth asteroids as a population. What I'm going to focus on just for a few minutes here is the DART mission here, which is the first of a 2-part project involving the DART mission led by NASA with support from the European Space Agency, and the Hera mission, which is by the European Space Agency with support from NASA. These both developed from a question of, if we find an asteroid that is going to hit the Earth, what can we do about it? The first thing is to have advance notice about it. If it is a really small thing, like the size of my desk, again, we just run towards the meteorites. If it's something like Chelyabinsk, you can evacuate a city if you need to. Or you can tell people to stay away from windows and hope they listen to the advice. It may be over the middle of the ocean and you just have boats stay away and it's not a problem. But if it's something much bigger, then we would want to have enough advance notice to stop the thing from impacting the Earth. How do you move around a really big pile of rocks in space? There's many different ways that have been proposed to do this. DART tested the most simple, conceptually, version of them. This stands for Double Asteroid Redirection Test. NASA and contrived acronyms are a long tradition. The idea, though, is pretty simple. We have a double asteroid system. We run the spacecraft into the satellite of the asteroid as fast as we possibly can. In this case, about 6 kilometers per second. The spacecraft is destroyed on impact, but all of the momentum goes into, we hope, the target asteroid, and then changes the orbit of the satellite asteroid around the larger asteroid. So this was done 3 and a bit years ago now. The DART mission ran into the asteroid Dimorphos, which is a satellite of the larger near-Earth asteroid Didymos. A camera was flown alongside of it by ESA. NASA built the main DART spacecraft, but the camera kept on going. It couldn't measure the change in the orbit. It could just confirm that the impact happened. So everybody is observing from the Earth to measure the change in the orbit of Dimorphos around Didymos. And it worked. This required some very careful programming on the part of the navigation team because this all has to happen automatically. The collision was 73 light seconds round trip time from the Earth, so no human on Earth can steer. Instead, they programmed the machine vision system to track images in the camera facing forwards on DART, find the smaller asteroid in the field of view of the camera, and aim at the middle of it. And that worked as intended. This is the last full image. The spacecraft impacted right there and produced a big cloud of debris. From the ground, the initial optical pictures were kind of confused because there's a big cloud of dust and ejecta from the impact. But with the radar observations, we can see through all that fine dust because the radar wavelength is much bigger than the dust was. And you can confirm that Dimorphos is in fact still in one piece, mostly, and it's been shoved along in its orbit around Didymos by a bit under 1 centimeter per second. Now, that doesn't seem like much, but if you have a centimeter per second of a velocity change for 30 million seconds in a year, you can move an asteroid far enough to change an impacting trajectory into a non-impacting one, if you have enough advance notice. So here we have at least one way of moving asteroids around in the directions we intended them to be moved. One safety note, it was a requirement for the mission that Didymos and Dimorphos cannot hit the Earth, and the DART impact pushed them very slightly further away from the Earth. Most of the orbit changes Dimorphos' orbit around Didymos, but momentum has to be conserved, so the whole asteroid system is also shoved along. But Didymos is 100 times more massive, so roughly. So that was a very minor change, and it was designed to push it further away from Earth for the minimum distance between its orbit and Earth's orbit. No creating an impact hazard while addressing the impact hazard. Okay. So I want to have time for questions here, but I do also want to note that there is a whole other rest of the solar system out there. So we talked about the main asteroid belt at the beginning. There have been several main belt asteroid missions. Dawn went to Vesta and Ceres. The various other spacecraft going out to the outer planets, of course, go through the asteroid belt. They have different points taken images of different asteroids. The Psyche mission is a NASA mission to go to the asteroid Psyche, which is a little confusing. That is an asteroid that barely survived a nearly disruptive impact. So we see mostly the metal-rich core of a larger object. So that's another aspect of planet formation. The Lucy mission is going out to the Jupiter Trojans. It'll fly through one cloud on one orbit and then through the other cloud on its next orbit. So it passes through the main asteroid belt several times and has flown by a couple of different main belt asteroids in the process. The UAE Space Agency is building its own asteroid tour spacecraft. And I put a question mark there for MMX, which is the Martian Moons Explorer. This is a JAXA mission to bring samples back to Earth from Phobos, which is one of the moons of Mars. Some of you may understand how Phobos and Deimos look like captured asteroids, but Phobos' orbit is really, really close into Mars. And getting something captured from an asteroid passing by Mars and ending it up in a circular orbit way inside synchronous limit around Mars is a tricky proposition dynamically. There's a few different ways it could have happened, but how much of them is Mars material that might have gotten ejected and how much of it is asteroid material that got pulled in is unclear. Hopefully MMX will resolve that, and they're to launch next year. I mentioned the Lucy mission. Again, it hasn't gotten out to its first pass through one of the Trojan clouds, but it has gone past a couple of different main belt asteroids. You see examples here from 2023 and from earlier this year. Dinkinesh on the left is a binary asteroid. The satellite is now called Salem. It looks very much like the binary asteroid systems I showed you in the near Earth groups before. It's just out in the main asteroid belt, the Yorp effects operate slower because there's less sunlight, but they do still work. Similarly, John L. Johansson looks a lot like the asteroid Tutatis I showed you on the previous slides. Another contact binary, just out there in the main asteroid belt. So studying the near-Earth asteroids does tell us about the main belt objects, which is reassuring because we can't afford to send spacecraft past all of the smaller main belt asteroids, and the radar resolution at that distance is nowhere near as good as for the near objects. All right, here is the rest of the outer solar system out to the Kuiper belt. Again, as of last week, although things this far out orbit much more slowly. Jupiter, Saturn, Uranus, Neptune, and the Centaurs are crossing the orbits of the giant planets. Those orbits are also not stable. The time scale for those being moved around is hundreds of millions of years, but we still have seen some that have had pretty dramatic changes in their orbits pretty recently. The Kuiper belt, again, out past Neptune, is stuff that never was densely packed enough to accumulate to give a single giant planet. And then the population was pretty severely depleted by Neptune migrating around and resonances sweeping through. It is actually fairly uniform all the way around in the Kuiper belt. It doesn't look that way, though. You'll see some narrow spikes going out. Those are where deep survey programs have stared into one particular small section of sky to try to find smaller Kuiper belt objects. And of course, there's more of them. But you don't see the smaller objects where you didn't look for them. So this spike right here is right behind Pluto, for example. And it's not actually more dense right behind Pluto. It's just those are the objects that happen to be where people were looking. Over time, those will eventually even out as we have the Kuiper belt objects slowly spin around in their orbits. All right, you understand that further out in the solar system, things get colder. If we have objects coming into the inner solar system from the outside, those ices then can evaporate off into space, and we get very dramatic comets. I was reminded recently that Comet Halley has actually now passed aphelion. It's on its way back. We are just past halfway between the 1986 flyby, the Jodo spacecraft of Comet Halley, and when Comet Halley next comes back. If anybody is making observing plans for 38 years from now. There's also, more recently, the comet Churyumov-Gerasimenko, which was visited by the Rosetta spacecraft. This has a shape that's another contact binary structure, but this is not from radiation pressure effects. This is from outgassing and material jetting off into space and just eroding its way through the comet. We do see situations where those jets change how comets spin because they're coming off-centered, and occasionally comets will explode because they just spin up and up and up and up and they fly apart. This happened with a comet called Comet Schwarzmann-Bachmann 3 quite some time ago. I was planning to observe it with radar, but then there were 6 pieces, and then there were 60, and then there was nothing but dust. So lost opportunity on that one. But it looked cool when it exploded. All right, but even out in the outer solar system, there are still interesting things happening. This is the Centaur Chariklo, which we understand now has a little ring system around it, probably with a shepherding moon that has not been seen. This was observed by a transit observation, so if you can chase shadows of centaurs and asteroids, you can learn interesting stuff. And in this case, the main body of the centaur blocks the light from the background star off completely, but it also briefly dipped out on either side symmetrically. So there's at least 2 rings around Chariklo. And there's been some additional observations since this one, 2013, that show that over the last 10 years, Chariklo's ring system is actually migrating around and changing. Dust is migrating in and out orbits, starting to clump up. So there is dynamical stuff happening further out from the sun. I have Pluto and Charon in here because New Horizons was cool. We also have the obligatory note that out at Pluto's distance, the large heart-shaped structure there is solid nitrogen ice. And Pluto's atmosphere, of course, is very sparse, but it's nitrogen too, and that is collapsing out as it is moving further out in its orbit from the sun. So again, very different processes from what we're used to on Earth or in regular geology, but it's what's normal out in the Kuiper Belt. Now, Arrokoth is a smaller Kuiper Belt object that is currently way behind Pluto. New Horizons spacecraft was steered to fly by it after it went by Pluto. It is another contact binary, but this one could not have formed the same way the others did. It's out too far for any outgassing or erosion to happen. It is out too far for radiation pressure torques to matter, especially for something that's 30 kilometers long, 20 miles-ish. So I'm still not entirely sure how this thing formed, especially with the really, really oblate larger lobe there. So some folks I know who worked with the New Horizons team are still trying to figure that out. And it's been 6 years now, and almost 7 years now, and still a little mysterious. This way we hopefully eventually learn new things. All right. There is also past the Kuiper Belt the Oort cloud. So stuff in the outer Kuiper Belt, the orbits get eccentric, they get perturbed by passing stars. The perihelions get raised to the point that they no longer interact with the planets dynamically much at all. Example here is Sedna. See its orbit there as compared to the orbit of Neptune. It is way far out there, but it's still only the inner Oort cloud. We know from isotropic comics coming in every which way, there's basically a spherical shell of objects out there, and occasionally they get scattered in, and only then can we see them. There is, last several years, been speculation of a so-called Planet 9 that would be a ninth planet further out than Neptune. The precedent here is that Neptune was found by Uranus's orbit being perturbed, and people did the math and said there should be a planet over there, and there was a planet. The argument now is if you look at extremely detached objects out on the inner Oort cloud, extreme Kuiper Belt, they look to be dispersed in certain ways around the sun, coming closer only in certain sections. There was a suggestion that there was a ninth planet out there that would be scattering the orbits of stuff in certain ways, and other orbits would be relatively stable. This would explain the structure of the inner Oort cloud. But there was a different suggestion, which is thus that we are finding the extreme Kuiper Belt objects where people are looking for them. And you see here a map of survey coverage for very deep Kuiper Belt surveys in 2021. So there's been a few more since, but the basic pattern remains. It's hard to observe the bottom and the top here because that's where the galactic plane is intersecting with the ecliptic, and it's hard to see things with all the stars in the background. Other surveys go deep in narrow spikes, and that's where you find the extreme Kuiper Belt objects. So there may not be a need for a ninth planet out there. Maybe if we find more Kuiper Belt objects, it'll just fill in all the way around. Or maybe there is a ninth planet out there and a new survey program will see it. One of the things the Vera Rubin Observatory will do is hopefully finally answer that question. And if there is a ninth planet out there, I'll be very excited. And if there's more Kuiper Belt objects out there, we'll still be excited, just not quite the same way. All right, I'm going to stop here and take what questions you have. It's already 10 to 9.
All right, thank you, Michael. So, yeah, so anyone who has a question, just unmute yourself and chime up. I don't see any questions posted in chat at this moment. So just shoot your question. Hard to believe. So with Vera Rubin coming online, I'm assuming you will start getting just reams and reams and reams of data, new data to
So
especially on the distant stuff.
this is actually great problem to have. And the Vera Rubin Observatory team has done a huge amount of work on this. The telescope is designed to be almost entirely automated. So it has a scheduled survey program. There's interrupts. They can break into it if they want to. But it's designed to do a particular scheduled set of observations, carefully scheduled around the weather and where the sun is and where the moon is, and try to find all the objects it can. and then takes a picture, takes another picture, every certain number of seconds. And then within a minute or so of the shutter closing on each image, it gets read out and processed. And within each image, they find everything that moves. And this is just one branch in the pipeline, the moving objects part of it. There's a whole other branch to find supernovae and variable stars. And then that list goes automatically live onto an API on the internet, and anybody can query it. So there'll be a branch for Kuiper Belt objects, there'll be a branch for comets, there'll be a branch for near-Earth asteroids, and then we all have to figure out which ones of those we want to do our own follow-up observations of. So 3,000 near-Earth asteroids per year, I triage and sort, and we have the radar team that I'm on as a program that does this for us. Now we'll just have to deal with 10 times as many objects and decide which ones we want to follow up and which ones we just don't have the time to do. So this is a great problem to have.
Yep.
All right, there is a question here, which is how are the named objects named? So there's different conventions here for different types of objects. Comets are by convention named after the telescope or the observer that found them. So Carolyn and Gene Shoemaker and John Levy found a bunch of comets, and that's how there was Comet Shoemaker-Levy 9 back in the 1990s. And that's how there is Interstellar Comet 3 Atlas right now. And I can talk about that for a few minutes if there aren't any other questions. But with the near-Earth asteroids, there's 3,000 of them per year, and there's many, many times that for main belt asteroids. So nobody is going to come up with a million names. Instead, each one of the objects gets this provisional designation, which is just a code assigned in order based on when it's discovered. So it's 2024 YR4, for example. And then eventually, if the orbit is confirmed well enough that we're not going to lose track of it again, it's given a catalog number. Apophis is 99942, for example. And then within that, for the near-Earth asteroids, there's the nomenclature committee of the International Astronomical Union, and the discoverers of an asteroid have the option of submitting a name if they want to. And there are some rules on that. You can't have them be too long. They can't be obscenities in any language. They do check that. You can't name it after any fictional characters, after somebody named an asteroid Mr. Spock once. And there's a few other rules too. Eventually, we just have accepted that nobody's ever going to name most of the asteroids just because the nomenclature committee can't keep up if there was to be 30,000 names to consider every year. So they give names to a few that people decide they want to name.
Hi, this is Tom Holman. I have a citizen science question for you. You mentioned that amateur astronomers are contributing to the study of the near-Earth objects. There's an Astronomical League project called Target NEOs where you submit RA and DEC information for tracking of asteroids. Is that actually useful for people like me who are submitting these things? Is that data actually used? And if so, how?
The data that I'm dealing with is run through the Minor Planet Center, which is run out of Harvard for the International Astronomical Union. They ingest astrometry from everybody who reports it in specific formats, and they check it against astrometry from other telescopes to make sure that nobody's put in the wrong time and nobody's done their standard stars wrong and nobody's confused which timestamp they're using on their star catalog and so on. And it works quite well, and there's an established community of amateur observers who do contribute.
Yeah, that's how this works. I've started that project, so
thank you.
I'm contributing to that.
There is a second set of things I mentioned a bit for Chariklo, which also gets applied to main belt asteroids and to near-Earth objects, which is occultation chasing. So in this case, there's the International Occultation Timing Association, and they have a list of these are asteroids that will fly in front of these stars in these points and these times. The trick there is having a bunch of telescopes that are portable, that you can set up in whatever road is convenient to having the shadow of the asteroid fly across you. But that has actually been quite helpful for the DART mission because they provided very good astrometry of where Didymos and Dimorphos were, which saved on the fuel margin a little bit. And it's also being used for the Destiny project to go to Phaethon, because its orbit is kind of perturbed by all of that gas and dust it keeps ejecting because it gets so close to the sun. So getting new astrometry really accurately every time an occultation can be caught has been very useful to the mission team.
How has the loss of Arecibo affected your research?
So the radar capabilities are not great. So Arecibo was the second largest telescope in the world for any radio observations. The FAST telescope in China, which is a bit bigger, was not designed to handle a really heavy radar transmitter up on the platform. It can't hold it. It's just receive only. So Arecibo was the most sensitive radar in the world by a factor of about 20. Now, that's less bad than it may seem in terms of the number of radar targets, because the radar signal to noise decreases as the fourth power of distance, 1 over r squared going out and 1 over r squared coming back. But losing Arecibo meant that the distance out to which we can detect an asteroid of a given size has decreased by about a little over a factor of 2. So we can see things half as far away. And that means 1/4 as many objects, and we can't absorb those objects for as long. So it has been a very big loss. There's plans and proposals for building a new radar facility, but it would cost a few $100 million to match what Arecibo could do. So far, nobody has been willing to invest that money.
Has the NASA cuts impacted any of the upcoming asteroid missions?
So under the current NASA shutdown rules, the missions are categorized as essential activity and they can keep working, although not everybody's getting paid, which is a problem. Other mission stuff, asteroid-related stuff may be classed as not essential and not happen. So it's kind of complicated right now. I'm not sure always who I can talk to and work on stuff with. In terms of longer-term NASA funding, we have no budget for next year, which does make things hard to plan. But the missions hopefully will go forward, especially those that are already in the sky, because keeping those running is a lot easier than building a whole new spacecraft.
All right, does anyone else have any more questions for Michael? All right, well, Michael, thank you very much. Great presentation, and we really enjoyed it. Hopefully, you'll have opportunity to join us again, talk about other objects in the sky or something like that.
We can try it at some point. And thank you
All
all
right.
again.
All right, thank you very much. I will.
Good night, everybody.
All right. I will take over sharing once again, and let me just wrap up the meeting here. 1 second. All right. All right. Again, thanks to Michael Busch for his great talk. And lastly, I want to talk about next month. So as we talked about, we've got a business meeting. It is our elections. So my plan is to take care of the elections as soon as possible, minimize some of the standard PSA kind of things. We probably will not have a member presentation in December. And then have our scheduled speaker, Todd Burlett, and then hold our Astro swap meet after the elections everything is wrapped up. So bring your stuff, bring your money, and we'll see you next month at the Andetu Techa Education Center in Roseville. And don't forget that next month we'll again do our pizza meetup after the meeting, and then have a beer and pizza and be great. So we will see everybody next month. Thank you for joining this month. Bye now.